Hi guys, in this video we're going to review, or I should not say review, we're going to expand on more common rules of integration, and specifically in this video we're going to cover exponential and logarithm integrals. So, the first thing we have to remember is that there's always a relationship between an integral and a derivative. When we integrate a function and get our output, if we take the derivative of that function and it gets back to our integrand, we know that we have successfully integrated. So here's an example. We know that d dx, or the derivative of e to the x, equals e to the x. And from this, we can say that then the integral of e to the x dx equals e to the x plus c. Because when I take the derivative of this right here, I get back to e to the x. So, we're going to do this with other functions. We know that d dx of ln of x equals 1 over x for x is greater than 0, because we can't have any number that is 0 or less than 0 in our input of our logarithm function, because then it's undefined. So, now what I'm going to do is I'm just going to say, alright, so the integral of 1 over x dx must be equal to ln of x plus c. Now, this statement is wrong. It is wrong because when we integrate 1 over x dx, we actually have to say the ln of the absolute value of x to represent if we have a negative number, that negative number becomes absolute value. And instead, we're going to write it like this. The integral of 1 over x dx actually equals ln of the absolute value of x plus c. And that's the correct statement. So now we've established two common integrals. Here's 1 and 2. Integral of e to the x dx equals e to the x plus c. And the integral of 1 over x dx, or x to the negative 1 dx, equals ln of the absolute value of x plus c. And there is one other common exponential and logarithmic integral that we need to be familiar with. Now, we know that d dx of a to the x, where a is some constant, equals ln a times a to the x. Alright, so from this, I must know then that the integral of a to the x dx, and this one we're not going to establish that relationship, but it's actually going to be equal to a to the x over ln of a plus c. Now, we can check that this is correct. And this is how we're going to check if a to the x over ln a plus c is the correct antiderivative of a to the x dx. We're just going to take d dx of a to the x over ln of a plus c. Well, I know that d dx of c, a constant, is just going to be 0, so I don't care about that. And now I'm solely just going to review d dx of a to the x over ln of a. Well, I am going to use the constant rule of differentiation. So I can rewrite this expression as 1 over ln a times a to the x. And we know that 1 over ln a is just going to be some, we know that 1 over ln a is just going to be some constant. So I can keep 1 over ln a like that constant. And this is going to be times. Now I have to take the derivative of a to the x. We know that's ln a times a to the x. And notice this. Ln a and ln a cancel out, and I'm left with a to the x. But doesn't that look familiar? Look at, that's what we had in our integrand. So we know that a to the x over ln a plus c is the result when we integrate a to the x dx. And these are our three main exponential and logarithmic rules of integration. So now let's do some practice problems. Let's say I said, what is the integral of 2 to the x dx? We'll start off simple. Well, that's just going to be ln 2, or excuse me, that is going to be 2 to the x over ln of 2 plus c. We can never forget about plus c. Okay? Now let's do the integral of 5e to the x dx. Well, that equals 5 times the integral of e to the x dx, which equals 5e to the x, that's the integral of e to the x, plus c. All right, let's try the integral of 3 over x dx. Well, I can say that's equal to 3 times the integral of 1 over x dx. And this equals 3 ln times the absolute value of x plus c. Now let's do one complicated example. Let's say we have the integral of e over x plus 7e to the x plus pi to the x dx. Well, by my sum and difference rule of integration, I can break this up and rewrite it as the integral of e over x dx plus 7 times the integral of e to the x dx. I'm just doing that constant multiple step, plus the integral of pi to the x dx. Well, for this e to the x, I'm going to, for this e over x, I'm going to take out that e and rewrite this e times the integral of 1 over x dx plus 7 times the integral of e to the x dx plus the integral of pi to the x dx. Well, now I can integrate. I know the integral of ln over x, the integral of 1 over x is ln of the absolute value of x. So here I get e times the ln of the absolute value of x plus 7 e to the x plus, okay, now we have to remember how to integrate a to the x, and it's always going to be pi to the x, so a to the x over ln of that constant pi plus c. And that's our result for that complex integral right there. So we did some example problems, and we also went over the rules that go with exponentials and logarithmic functions. And we can see it's all summed up here. Now stay tuned. In the next video, we will go into the most common rules of integration for trigonometric functions.